Okay. All right. Hello, everyone. So sorry about that. I'm just going to give a minute or so just for everyone to join again. Sorry about that. Oh, what a mission. Thank you for the likes, guys. Sorry about that. This phone and the network, it just wasn't it just wasn't cooperating. So sorry. There were about 50 people on, so I'm just gonna wait until we get to about 40. When will I be live again? I'm not sure. Probably only next weekend. Okay, are people joining? Yes, thank you. Yeah, guys, thank you for sharing. If you shared before, I'm going to ask you please to just share again, because I think maybe because I closed the live and came back on, the link that you might have shared in the first place is not working now. Thank you so much. Yeah, I do usually only go live on weekends. I was saying earlier, I have extramural stuff on every single weekday, like on a Monday, Wednesday, and Thursday. I have to be at netball practices and matches. On a Tuesday, I have an appointment with my little girl every week. And then on Friday afternoons, I tutor. So, yeah, I have a very tight schedule, unfortunately, but I will let you guys know when I go live. Please just make sure that you are following so that you get an announcement, or not an announcement, a notification when I do go live. Okay, guys, we are back at 50. Thank you so much. Let's see. Yes, I will post this to YouTube. Okay, so sorry about that, guys. Hopefully everything will be okay now in terms of network and my phone overheating. So we were looking at this example, and as I was saying, when you have multiple terms in a trig equation, usually, I'm not going to say always because there are some exceptions to the rule, but usually you need to factorize. So the first thing that you're going to have to do is you're going to have to move this cos x over to that side. This is grade 11, but it is an extension of grade 10 stuff. So if you are in grade 10, you can listen, but you won't necessarily get a question like this in grade 10 yet. The grade 10 questions, they don't talk about general solution, and you also don't have to factorize yet. So the grade 10 ones aren't as tricky as this one. So guys, like I said, this cos x, you move that over to the other side. It's positive cos x here. When you move it, it becomes negative cos x. Then you're going to take out cos x as a common factor. Now remember, when you're taking something out as a common factor, you actually have to divide each term by that common factor. So root 2 sine x cos x, when you divide by cos x, you're just left with root 2 sine x. And the next term, negative cos x, when you have negative cos x divided by cos x, it's negative 1. So someone was asking earlier, where does the negative 1 come from? It's because when you are taking out a common factor, you're dividing that last term by that common factor, which will give you negative 1 equal to 0. Okay, now we have a product of two things here, two expressions equal to 0. So we make both separate expressions equal to 0, like I have here. For cos x equal to 0, we are going to have to solve that just now. I'll do that next. But here, I just actually want to get sine x on its own first. So we're going to say that root 2 sine x, let me not do that all in one step, is equal to 1, right? That negative 1 you move across, it becomes positive 1. So then sine x is going to be 1 over root 2. Okay, now from here, you're going to have to find your reference angle and so on. Let's first just look at cos x equals 0. Now, I'm not sure how your teachers teach you how to do the general solution. I always teach my kids that they must find the reference angle first. And then they're going to work in the correct quadrants to get their general solutions. But in order to decide which quadrants you must work in, you must know whether this is positive or negative. Now, 0 is not positive or negative, right? It's in the middle. So for this, what I always tell my kids to do is to think of the cos graph. Now, if you think of the graph of y equals cos x, okay, I'm not sure if you guys have done cos graphs or trig graphs yet in grade 11. I'm doing it with my kids right now, actually. if you're thinking of y equals cos x, I'm just going to draw a very rough sketch here. You have your y-axis, you have your x-axis. The cos graph starts at 1, right? It goes down to 0, back to 0, and then back up to 1. So at 0, cos x equal to 0, where is that, right? At 90 and 180. Okay, if you haven't done cos graphs yet or trig graphs yet, then don't stress. You will still do those. But that's what I always tell my kids to think of when it's 0, because 0 is not positive or negative, right? Then I tell them you need to think, where is the cos graph equal to 0? Okay, and it is actually at 90 and 180. Now I'm going to just try squeeze this in here. What I'm going to do, sorry, let me actually just move this a little bit to the side because it's a bit cramped here. Guys, remember with a trig equation, right? Because a trig graph, a cos graph in this case, repeats itself every 360 degrees, right? That's what the period of the cos graph is. If it's 360, that means that every 360 degrees, the graph repeats itself. So we have to write plus 360n after our 90 plus. Okay, we can't just say that it's going to be equal to 0 at 90, because it's going to be equal to 0 at 90 and then every 360 degrees after that. Yes, so I'm going to get to that now. I see the suggestion there. Absolutely, you can do that. All right, so 90 plus 360n, n element of z. Guys, you have to write this the first time that you show n. Okay, so that was the one place on the cos graph that that the cos graph was equal to 0, was at 90 and at 180. All right, so that's the other one. Now, Nkuna is saying, why don't you just say cos inverse of 0? You can absolutely do that, right? Let's see what happens. If we do shift cos of 0, we get 90. Okay, sorry, I don't know if you guys can see that. There we go. You get 90, which is that answer. But the only problem is that it's not going to give you the next one. It's not going to give you the 180. Okay, so for that, yeah, that's why I tell my kids rather think of the graph, or you can do your cos inverse of 0 to get this one, but then you need to think, what about the other option? Okay, so I teach my kids to think of the cos graph. All right, so that is the first one, cos x equals 0. The other one here, we now need to find the reference angle here. Now guys, 1 over root 2, this is a positive number. Okay, so this is saying that sine of whatever this angle is that we're going to get now must be equal to positive. Now, in which quadrants is sine positive? Sine is positive in quadrants 1 and 2. All right, that's a little cast diagram, a little Cartesian plane that I've written there. Cos 180 is plus minus. I'm not sure what you mean by that. But okay, I'm going to carry on here. So sine is positive in the first and second quadrants. Okay, so what you do, I'm going to write here for your reference angle. You do sine to the negative 1 of 1 root 2. All right, so let's do shift sine root 2. Oh, sorry, that's off screen. And our reference angle is 45 degrees. All right, so the reference angle is 45 degrees. So now, guys, we need to do a quadrant 1 solution, because in the first quadrant, sine of any angle in the first quadrant will be positive, but then we need to do a second quadrant solution as well. Okay, now you don't have to write Q1, but I usually do, just to kind of keep track of what I'm working with. So quadrant 1, we're going to say x is equal to, and guys, in the first quadrant, you just work with your reference angle. Okay, so in the first quadrant, it's just going to be 45. I hope that we all agree that 45 degrees is an angle in the first quadrant. Okay, so we're just going to say 45 degrees plus 360n. Now, because I've already written n element of z, n is an integer, here at the top you don't have to write it again. Okay, you only have to write it once. So that's the first quadrant solution. The second quadrant solution, guys, to get your equivalent answer, the angle that will give you the same value in the second quadrant, you're going to have to take 180 minus that reference angle. Okay, so we're always using the reference angle to get the angle in the specific quadrant. So when we're working with quadrant 2, we're going to say 180 minus 45 degrees. You don't have to write it down as a separate step. You can actually just work that out on your own, but I'm just trying to write everything down here. All right, so this is 135 degrees plus 360 m. All right, so that's quite a long example because we first had to move something across, then we had to factorize, we had to make each part equal to 0, and then we had to solve each of them. All right, so that was quite a long question, but that was worth 6 marks. Okay, I'm going to move on to the second question. All right, so this was also from a past grade 11 exam paper. So this one is now saying determine the general solution of this. Now guys, this is similar to what we had earlier. All right, we had 2 separate terms. So can anyone remember what I said for the first one? What do you have to do when you have 2 separate terms? Can anyone say in the comments, what must you do with a trig equation if you have, hi baby. Hello. Mommy's teaching. Can no one remember when we have multiple terms, what do we need to do? Take it to the other side. Yes, thank you. Transpose. That's not a word that I use, but okay. All right, good. So let's try that. And guys, also sometimes it might not work, right? That's the thing with trig. And especially when you're doing something like identities, often you just need to try something out and see if it works. Okay, make it equal to 0, correct. Now, in the previous example, when we did that, right, when we had made it equal to 0, we were able to just factorize. We were able to just take out a common factor. Now here, it's not actually as easy as that, right? So we can't equate them both to 0 yet. We have to have a product of 2 things. If we look back at the first example, we had a product of cos x and a bracket. Then we could make each of them equal to 0. Okay, so here we still have 2 separate terms. So what do you guys think? Does anyone have an idea of what we can do here to actually solve for x, or to get this in a simpler form so that we could possibly factorize? Are there any ideas? I'm watching the comments, and if someone says something that sounds like a good idea, then we'll try it out. Change tan. Yes, let's try that. Okay, let's change tan to sine over cos. So 3 sine x minus 2 sine x over cos x. And that is then equal to 0. Okay, now guys, we have a fraction. Okay, and what we need to do whenever we have an equation with fractions is we need to get rid of that denominator. That is, so factorize sine out. Yes, you could do that at this step, but then you're still going to have a fraction. Okay, so that's perfect. If you want to do that, you could take out sine x as a common factor right now already. I'm actually just first going to get rid of that fraction. I don't like working with fractions, especially going forward if we're going to try and you know, make brackets equal to 0. So what I'm going to do, and I'm not sure if you learned this in lower grades, is whenever you have an equation with fractions, multiply each term by the denominator, right, or the LCD of the fractions. Yes, well done. Multiply all the terms by cos x. Okay, so that's what I'm going to do. I'm going to multiply this term by cos x and that term by cos x, and actually this one as well. All right, it is 0. So I'm just going to multiply each term by cos x because that will then get rid of that denominator. Okay, so we're going to have 3 sine x cos x minus 2 sine x equal to 0. So what happens here, yes, correct, we have 3 sine x cos x, right? When I multiply this term by cos x, this is what I get. When I multiply this term, which is 2 sine x over cos x, when I multiply this by cos x, the cos x's are going to cancel each other out. Okay, now guys, this actually looks very similar to the previous example. If we just go back to the previous one, do you see how similar that looks, right? We have two terms with a common factor in both. Do you see that we have a common factor of sine x in each of these terms? All right, so now in the next step, we're actually going to take out sine x as a common factor. So we have sine x, we're left with 3 cos x minus 2 equal to 0. Yes, correct. Sin x is a common factor. We're taking it out as a common factor. Well done, guys. Okay, so now we have a similar situation as in the previous question. We're now going to make sin x equal to 0. Or this whole bracket we're going to make equal to 0. 3 cos x minus 2 equal to 0. All right, now we're going to solve each of them. So here again, because it's 0, I'm going to think of the sine graph. So I'm just going to draw a rough sketch here. The sine graph starts at 0, right? And then it does that. So where is the sine graph equal to 0? At 0 and 180, and actually also 360, but we don't have to write that, okay, because 360 is just a repeat of 0. So my two solutions are going to be 0 plus 360n, and then 180 plus 360n. Thank you so much for the follows, guys. Sure, I really appreciate it. Let's see. So we have x is equal to 0 degrees plus 360n. And if this was the first question that you were doing, you would have to write n element of z. Okay, I've already written it over here, so you don't have to write it again. Okay, but whenever you're using it for the first time in a test or exam, you do need to use it. So x equals 0 or x equals 180 plus 360n. Okay, those are the two places on the sine graph where it is equal to 0. So there, we're done with that side. Okay, let's finish up this side. We need to make cos x the subject. So we're going to have 3 cos x equal to 2, right? I'm moving that minus 2 over. It's becoming positive 2. And then I'm going to divide by 3. So cos x is 2 over 3. All right, now you need to ask yourself, in which quadrants will cos be positive? All right, if we're looking at our, oh, that's very skew, sorry. If we just draw a small, it's not much better. Anyway, if we draw a small, yes, you can use a k in the place of n. Absolutely. Lots of teachers prefer k, actually. 100% you can use any variable. I was just taught with an n, so I prefer that. I'll explain what that means now. Yes, quadrant 1 and 4, correct. Okay, so first things first, we need to find our reference angle. Now, to find the reference angle, you're going to say shift cos of whatever this number is, 2 over 3. And our reference angle is, what's that, 48,19 degrees. Okay, that is the reference angle. Now I'm going to do a quadrant 1 solution, which remember we've already discussed in the other example that in the first quadrant, you just have any angle between 0 and 90, right? Acute angles. So we're going to use the reference angle in our first quadrant. So x is 48,19 degrees plus, I feel like I'm running out of space. Yes, let me just move this up a bit. I'm actually going to take away this diagram. Then let me just move this a bit to the side. Otherwise, it's not going to fit in. Okay, plus 360n. All right, that is the first quadrant solution. Now, the other quadrant where cos is positive is quadrant 4. Now, in the fourth quadrant, there are two things that you can do. You can either just do this reference angle, but the negative version of it. So you can write negative 48,19 plus 360n. All right, that's perfectly fine. You can write that. Or you can do 360 degrees minus your reference angle if you prefer. Sorry, let me just move this again. Don't have enough space here. You can do 360 minus your reference angle. Okay, both of these will get you the marks. Oh, that was a squeeze. All right, let me just work that out quickly. So that is 311,81 degrees plus 360n. Okay, so you can decide, guys. You don't have to write both of these. You can either write that one, just the negative reference angle, or you can do 360 minus the reference angle. It's entirely up to you. Okay, you can decide. So someone asked what the n element of z means. That means that this n variable, or k, as quite a lot of teachers use, that we are introducing here. Remember z, right? This symbol, that is the symbol for integers. All right, you're supposed to learn that in, I'm actually not sure what grade they teach it in. We only teach it in grade 10, but I think you start working with it in grade 8 actually. So you might learn the proper definition of integers then. Integers are basically positive or negative whole numbers. All right, so we're just saying that n, when we say n is an element of z, we're saying that n is either a positive or a negative whole number. All right, that's what that means. Some teachers use z. Okay, that's interesting. I've never seen z before. Grade 12, yeah, that's fine. Okay, whatever, let me just take this away here. Whatever variable your teacher uses, it's fine. You can use any variable. No, this is just, maths. Maths doesn't have a nationality, I suppose. Okay, number 3. But I am South African. We do this in South Africa. All right, number 3. Determine the general solution of this. Now, this is quite a common type of question, guys. Sine x minus 30 equals cos 2x. Now, the reason why in examples 1 and 2, we were able to factorize is because we were working with the same angles in all of the cases. So here we had x, x, and x, all right? We could take out a cos x because we had the same angles. Here, again, we have x's everywhere. We have the same angle, so we could take all the angles out, all right? Now, for this one, I'm seeing that someone is suggesting compound angles, so I actually wouldn't work with compound angles here because it's going to make it much more complicated. Let me just show you quickly what's going to happen if you do work with compound angles. And I'm so glad, Simanga, saw that you said that because lots of people make that mistake. Okay, so thank you for making that comment. If you used compound angles, right, you're going to do this. You're going to say sine x cos 30 minus cos x sine 30 equal to cos 2x. Okay, now that's not wrong, all right? We did expand this correctly, but actually I've made it so much more complicated. All right, so I wouldn't suggest that you do that. I wouldn't suggest that you use compound angles here. Actually, you don't actually ever have to use compound angles in trig equations to expand. Sometimes they'll give you the expansion, right? They'll give you the separate terms and you have to put it back into this. All right, but what we're going to do here, and someone did make the suggestion, we need to get the same trig ratios on both sides. So I have a sine on this side, I have a cos on this side, and again, yes, this is a double angle, but if I change this to any one of the 3 double angle identities, it's going to be so much more complicated. All right, yes, you change. So someone's saying change sine into cos. I'm actually going to change cos into sine just because that would be the easier one. Mukelo, yes, you are going to use co-ratios here. So this cos of 2x, I'm actually going to change into sine of 90 minus 2x, and that is the key to this question. All right, to this type of question. Let me just actually rewrite this. So we have sine x minus 30 equal to sine of 90 minus 2x. Guys, this is now actually such an easy equation to solve. They have given us the reference angle. The reference angle, in this case, we don't even have to calculate it like we did in the previous examples. We don't have to do a shift sine of a number or shift cos of a number. The reference angle is actually exactly what we have on this side. Okay. Yes, you use this in trig functions, correct. All right, guys, so here, this is what you need to do. If you see sine of an angle equal to cos of a different angle, right? Sine of an angle equal to cos of a different angle. You need to change one of them to the other one by using co-ratios, by doing a 90 minus. Okay, so now from here, it's actually going to be very simple. What I want you to notice is that this is positive sign. Okay, there's no minus there. Sometimes there might be a minus. So if they said, for example, negative cos 2x, then you would work in the negative quadrants. Okay, but this is positive cos. So we are going to work in the quadrants where sine is positive, which again is quadrants 1 and 2. You always work in the quadrants that the ratio on the left, right, is positive or negative based on the sign of this one. You have no clue that you could do that. Okay, well, I'm glad that you've learned something. All right, guys, so now we're going to jump straight into our two quadrant solutions, all right? So as easy as that. We've just changed cos 2x to sine of 90 minus 2x. That is our reference angle. So now we're going to say for quadrant 1. What we need to remember now, though, we can't say x equals like we did in the previous questions. Let's see. In the previous questions, it was cos x equal to 0. So we said x. Right, here we had sine x equal to this, so we said x in our general solutions. When you have x minus 30, you have to actually say x minus 30 is equal to. In the first quadrant, we just use the reference angle, which is 90 minus 2x. And then because the period of sine is 360, we say plus 360n or k or whatever variable you want to work with. So the question is, do you drop the sign? It looks like you are dropping the sign, but what you're actually saying is for this side to be equal to that side, right? For sine of an angle to be equal to sine of another angle, the angles have to be equal to each other. Okay, so in a sense, yes, we are dropping the sign, but we're almost just saying that this angle has to be equal to that angle for this equation to be true. Okay, now guys, we need to solve for x, right? So we need to get all the x's on the one side. So this minus 2x, I need to move it over. It's going to become plus 2x. We already have an x here. X plus 2x is 3x. That is equal to, we have a 90-degree angle here. This minus 30, I need to move across. It needs to become plus 30. 90 plus 30 is 120 degrees, and that is plus 360n. Okay, we're not done yet. We still need to do 3. We still need to divide by 3. Okay, so x is then 120 divided by 3 is 40 degrees. Plus, this you must also divide by 3, guys. 360 divided by 3 is 120n. Okay, plus 360k. Yes, that's perfect. You can say that. Okay, so that is our first quadrant solution, guys. This equation will be true if x is 40 degrees, but then also every 120 degrees after that. Okay, that is our quadrant 1 solution. The quadrant 2 solution is going to be a bit more complicated because what do we do in the second quadrant? We say the angle that we're working with, x minus 30, is equal to, in the second quadrant, it's always 180 minus, all right? 180 minus the whole reference angle. Now, the whole reference angle is 2 terms. So, guys, you have to put it in brackets, please. All right, 180 minus the reference angle, which is 90 minus 2x. And that, again, we do a plus 360n. All right, now before we start moving things across, let's actually just multiply out these brackets. So minus 90, that's a negative 1. When I multiply it by negative 2x, I get positive 2x plus 360n, okay, or whatever you use. Now I'm going to start moving things across, all right? So now this plus 2x, I'm going to move across to that side. It's going to become minus 2x. So we have x minus 2x. That's negative x. All right, so we're ending up with a negative x. Now it's not a problem. We have 180 minus 90. That's 90 degrees. Then this negative 30 is going to become positive 30. So we have 90 plus 30. That is 120. plus 360n. And now to get rid of that negative 1 in front, we just need to divide each term by negative 1. So we're going to get negative 120 minus 360n. Okay, it's just like solving for x in a normal equation for these parts. Can you please repeat second step? The second step is this one that you're referring to. The first step was changing cos 2x to sine of 90 minus 2x. And then here, this line here, just check. I'm not sure what you mean by second step. I'm not sure if it's that step or this one here. But what I did here was in the first quadrant, if we have sine equals sine, right, then we can always say that the second angle is our reference angle. Oh, from Q2. Okay, cool. So Q2, we say that this angle, x minus 30, is equal to, in the second quadrant, we always use 180 minus our reference angle. So 180 minus the reference angle is now 90 minus 2x. So because we are subtracting multiple terms, we have to put those in brackets. All right, then what I did here is I just took this negative 1 in front of the bracket and I'm multiplying it in. So I'm saying negative 90, and then a negative times a negative is a positive 2x from there. Okay, that is the whole question on that one. This was a 5-mark question. I'm assuming that they would have done 1 mark for changing cos 2x to sine 90 minus, 1 mark for that, 1 mark for simplifying, 1 mark for that, 1 mark for simplifying. Someone asked, you are welcome, someone asked if you could have changed this cos 2x to sine of 90 plus 2x. Now, in this case, actually, that wouldn't have worked because sine of 90 plus 2x, I'm just going to write it here at the bottom, sine of 90 plus 2x. Now 90 degrees plus an angle is in the second quadrant. And in the second quadrant, oh, actually it would have worked. Yes, sorry, that is correct. In the second quadrant, sine is positive. So yes, sorry, it would have worked. Yeah, you could have done that. You could have written it as 90 plus 2x. Your answers then would have differed slightly, but it still would have meant the same thing. All right, so you could have done that there. That's no problem. Okay, any other questions on this one, guys, before we move on to the next question? Oh, sorry. Let me just take a sip of water here before we carry on. Okay, this one, number 4. I think this is probably the last one that we are going to have time for. But this is an interesting one, right? This is a one with fractions. Oh, one. This is one with fractions. Sorry about that. Okay, how did you get 360? 360, so this 360n has to do with the period of a sine graph being 360 degrees. So that's where that 360 comes from. So for a sine and a cos equation, you always say plus 360n. And for a tan equation, because the period of a tan graph is 180, you will say plus 180n. Someone said earlier that they're from the UK and it's completely different in the UK. I'm quite interested to know how you would do this in the UK. So if you can maybe take a picture of an example or something and email it to me. If you're still on this live, I don't know if you are. That would be really cool for me to see how that works. Okay, guys, number 4, determine the general solution of cos theta minus 1 over cos theta equal to 5 over 6. Now, guys, this is, of course, a trig equation, but it is also an equation with fractions. And what I always teach my kids, as soon as you see that you have an equation with fractions, get rid of those fractions, okay? We don't like working with fractions. It complicates things unnecessarily. And the easiest way of getting rid of fractions in an equation, so I'm going to write here equation with fractions times every term, even the terms that are not fractions, guys, every single term, by the LCD, all right, of all the fractions that you have. Yes, correct, Simangaliso. Find the LCD, and then we are going to multiply every single term by that LCD. Now, if we look at this equation, we have two denominators. We have cos theta and we have 6. So the LCD in this case is 6 cos theta. So I'm going to multiply every term by 6 cos theta, and that is then going to get rid of those fractions. So this I'm going to times by 6 cos theta, that I'm going to times by 6 cos theta, and that I'm also going to times by 6 cos theta. Now, our first term is not a fraction, right? So we're just going to do this as a straightforward multiplication. 6 or cos theta times 6 cos theta is 6 cos squared theta. All right. The next step, minus 1 over cos theta times 6 cos theta. Now, guys, here the cos theta at the top is going to cancel out the cos theta at the bottom. So what we're actually left with is minus 1 times 6, which is minus 6. All right, so see, just by doing that, we've already gotten rid of that denominator. This term is now no longer a fraction. So someone is asking, why 6 cos x and not just cos x? Because I have a second fraction there. Okay, I want to get rid of that one as well. So I need to multiply by the denominator of that fraction as well to get rid of this one. So now that's what happens here. The 6 at the bottom and the 6 at the top are going to cancel each other out. I'm left with equals 5 cos theta. Now, guys, this is a trig equation, but also a quadratic equation, right? This is actually going to give us a trinomial. So let's get everything on the one side equal to 0 so that we can factorize this trinomial. Okay, now this is a complicated trinomial to factorize. If you are good at factorizing trinomials that have like a 6 in front of the square term, then you can do that. But let's just quickly practice using the quadratic formula. So you're going to say cos theta is equal to, hopefully we all know the quadratic formula by now, right? I'm just going to write it out actually. It's minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, and we remember that a is 6, b is negative 5, and c is negative 6. Okay, those are the values that we use. Yes, so yeah, you can do that if you have the silver calculator. If you don't have the silver calculator, then you can't use that function. So yeah, and also you will lose a mark if you just go straight from this line to your answers. Okay, you have to either show your factorizing step or you have to show the step where you are subbing in your values. So the step that I'm going to write down next, you have to show the step to get a mark. So even if you are using the calculator shortcut, you still would have to write the step down. Okay, so b squared is negative 5 squared minus 4, a is 6, and c is negative 6, so that is the square root, and that is then all over 2a, so 2 times 6, like that. All right, now we're going to get two answers from that. Okay, I'm actually going to write here cos theta is equal to, I'm quickly going to type it in here off screen. You guys can do the same. So 5. And remember, you're going to get two answers from this. The first answer you're going to get when you say negative 5, which is just 5 plus all of this over 12. The second answer, you're going to go back to the plus, delete it, and change it to a minus. Yes, this is the quadratic formula. Okay, so the square root of negative 5 squared minus 4 times 6 times negative 6 over 2 times 6, which is 12. All right, so the first answer that I'm getting is 3 over 2. All right, that is the first answer that I'm getting. Or the second answer is now, I'm just going to show you quickly on the calculator, right? This is what I typed in. Now, guys, to save time, please don't clear the whole thing and go back. Sorry, my screen looks terrible. Go use your arrow to the plus, delete it, and change it to a minus, and then just press equals. Okay, and we can see that the second answer is negative 2 over 3. Okay, so now we have two separate trig equations that we need to solve. I'm just going to move this one at the bottom down because we need some more space. Okay, now guys, we need to solve these each separately. All right. Cos theta equal to a positive value. Now, where is cos positive? Cos is positive. We have spoken about it before in quadrants 1 and 4. For this equation, cos is negative, right? It's a negative number. Now, cos is negative in quadrants 2 and 3, all right? So now, for this, we're going to have to find our reference angle. Now, guys, you're going to see something interesting happening with this first one. When you type in shift cos 3 over 2, let me show you what happens. Shift cos, I hope you can see that, 3 over 2. Do you see that it says math error? Guys, 3 over 2 is 1.5, right? And if you think of the cos graph, you see it is quite important to know your graphs because I keep referring to them. If you know your cos graph, right, the graph of y equals cos x, it starts at 1, goes down to 0, down to -1, back up to 1, and then it repeats that shape the whole time. It's never actually going to go to 1.5. Okay, so there actually is no answer for this. At no point will cos ever be equal to 1.5. So when you see that on the calculator, when you see math error, when you're trying to find your reference angle, right, then you know that there is no solution for this answer, for this equation. All right, so here you are just going to have to write no solution. Okay, as soon as you see math error on your calculator, you can just go ahead and write no solution for that part. Okay, the second one is going to have a solution though. I'm just going to move this up a bit to that side so that I have more space. So let's find this one. I'm from South Africa. Now this one, guys, we haven't had one where we have a negative value yet. Okay, when you are finding your reference angle, you are not going to type in that negative value. You are actually going to do shift cos of positive 2 over 3. All right, I don't know if your teachers have taught you like this, but this is how I always do it. So you do shift cos 2 over 3, all right, and then you get, what is that? 48,19 degrees. Oh, I feel like that's something that we got in another example earlier. 48,19 degrees. Okay, so please, guys, when you're finding your reference angle, you do not type in the negative. You type in the positive. To bring that negative into the mix, we're going to work in the quadrants where cos is negative. Okay, so we're going to have a quadrant 2 solution. What is my angle in this equation? Theta equal to, what do we do in the second quadrant again? It's always 180, right? Second quadrant is always 180 minus, your teacher never told you this. Sorry, maybe she didn't have time or something. I'm not sure. Let me just move that over to the side. I don't have enough space here. Remember, for quadrant 2, we always do 180 minus the reference angle. Okay, so that is how we are bringing that negative number into the mix, by working in the second quadrant. Okay, again, plus 360n, because it's cos, the period of cos is 360. Okay, so what is that? I'm just going to work it out quickly. I think we did have it for another example earlier. 48,19, that is 131,81 degrees plus 360 n. Okay, so that is the second quadrant solution. Again, I'm working in the second quadrant because this is saying cos must be negative, and cos is negative in the second quadrant. For the third quadrant, because that is the other quadrant where cos is negative, for the third quadrant, we haven't worked in the third quadrant yet. It's always 180 plus the reference angle. All right, so we're going to say for quadrant 3, theta is equal to 180 degrees plus 48,19 degrees plus 360n, and now we just need to work that out. Okay, so 180 plus 48,19, that is 228,19 plus 360n. There we go. Let me just move this down a bit more. Someone was asking what app I'm using. This is GoodNotes. Okay, there we go, guys. That is it. That is the answer to this equation. All right, so we first had to multiply each term by the LCD of both of these fractions in order to get rid of those fractions. Then we saw that it is a trinomial, so we moved everything to the one side, made it equal to 0. Then we factorized by using the quadratic formula, but you could have factorized that trinomial as well if you wanted to. And then we got our two answers and we solved the two equations separately. What is 360n? So that is just saying that because if you use n in an exam, you won't be penalized. No, you won't. But if your teacher is using k, rather work with k, because your teacher will mark your like June and your September exams. Your external exams will be marked by other people. So yeah, maybe just, I mean, they can't really mark you wrong, but rather just do what your teacher taught you. It is sometimes quite frustrating when, yes, because it's general solution. It's quite frustrating sometimes when your kids are writing something down that's completely different from what you taught them. Just because you can then see that they got help from someone else. So yeah, maths grade 8 classes, I'm not sure yet. I don't know when I'm going to go live for grade 8 again. I'm just going to go up quickly, guys, and see which questions I might have missed. Save you at least 25 marks in your exam. Awesome. I'm so glad to hear that. Is it wrong to say 270 minus? Yeah, so I would never work with 90 plus and 270 minus, because then you actually starting to work with co-ratios. So please work with 180 minus and 180 plus, and for quadrant 4, 360 minus. Okay, don't work with 90 and 270, because then you're actually supposed to change the trig ratios using co-ratios. I'm just going up quickly. Where in South Africa? I am in Cape Town. How will you know when to use the roots formula? So whenever it's a quadratic equation, you can use the quadratic formula to solve for this equation. But you always have to show it. Is it okay to write undefined? Undefined. The thing is, they're asking you to solve for theta. So I would rather say that it's not that theta is undefined. It's just that there isn't actually an answer for theta here. So I would rather write no solution instead of undefined. Okay, I think I've seen all of the questions. Now I'm just going down again quickly to see some of the new ones. Yes, if it was tan, you would say 180n. Correct. That's absolutely correct. 360n because the question asked to solve the general solution. Yes. The sign 90 minus 2x is something you wouldn't have thought of. Okay, you are welcome. I'm glad that you saw something that you wouldn't have thought of. Okay, cool, guys. I'm going to have to sign off now. I need to go spend some time with my family and get ready for the week. Thank you so much for joining. I hope that this was useful. Oh, and I see 19 people shared. Thank you. That's really cool. Thanks so much, guys. And for all the new followers, welcome to my account. I am going to go live again next weekend. I will decide during the course of the week still what I'm going to go live for. But if you have specific requests, please comment on any of my videos that I'm posting. I post every day, so you can just comment and just ask me if you want me to go live for anything specific, and I'll make a note of what people are requesting. Yeah, and good luck for the week, guys. It is a short week if you are in South Africa, at least Monday to Thursday. You are also my family. Yes, but I've just spent an hour with you guys. Okay, I will post this one on my YouTube. It will definitely be live on there by tomorrow. It just depends on how long it takes for TikTok to actually save it. The app that I'm using is Good Notes. It is actually free at the moment. You can have 3 notebooks on here if you download it for free. It used to just be paid, but now you can actually try it out. You can get 3 notebooks, which is really cool. I really like this app. Yeah. Thank you, guys. Have a fantastic week. I will see you next week. And I'm posting a really cute video with Miss Angler later tonight. If any of you guys follow her and you want to see a very cute video that the two of us made together, I'm going to post that in about half an hour's time. So keep an eye out for that. Thank you, guys. Have a lovely week.